Good afternoon. I'm Arun Serafin, Executive Director of the Emerging Technologies Institute at the National Defense Industrial Association. Thank you to all attendees for your support of NDIA and ETI, and thank you for joining us for today's webinar, Digital Supply Chains 101, with Dan Johnstone and Kevin Gaudet. This webinar is part of our Tech 101 series, where we try to distill complex technological concepts into introductory webinars with a focus on their national security impacts. Streamlined and efficient logistical capabilities have always been a critical component of warfighter success. To maintain this efficiency, the Department of Defense and Defense Industrial Base are undertaking an ambitious effort to digitize their supply chains. Digital supply chains bring substantial advantages over traditional approaches to defense logistics, from improved acquisition timelines and accelerated design reviews to automated decision-making and just-in-time part delivery. Digital supply chains will foster collaboration throughout the logistics community, allowing program managers, contracting professionals, engineers, logisticians, even financial managers and test professionals to collaborate seamlessly in real time. However, many critical steps must be taken to ensure the widespread adoption of digital supply chain technologies and practices, including ensuring access to digital material management tools, training a digital workforce, instilling a digital-first culture, developing digital strategies, structuring and securing data, and modernizing IT infrastructure. This presentation will discuss the basics of digital supply chains, illustrate the importance of digital supply chains to the Department of Defense, and provide an overview of ongoing DoD, commercial, and government activities to develop and implement digital supply chains across the defense enterprise. Some administrative remarks before we get started. One, all attendee lines are muted. Second, if you have a question during the webinar, you can submit your question in the question box in the webinar panel on the right side of your screen. We'll do our best to get through all the questions during the Q&A. Third, we're recording today's webinar for members unable to attend and for any member who wishes to review the material at a later date. And we'll post the recording to our YouTube channel for your review in the next few days. Now I'd like to introduce our speakers, Dr. Dan Johnstone and Dr. Kevin Gaudet. Dr. Dan Johnstone is the Associate Vice President and General Manager for Advanced Solutions and Products at Linquist, where he leads work on data analytics, artificial intelligence and machine learning, and software architecture and engineering. Dan's a retired Air Force logistics officer whose service included time in Afghanistan and work at the Air Force Logistics Management Agency. He earned a PhD in Operations Management and Decision Sciences from Indiana University. Dr. Kevin Gaudet is the Senior Vice President for Integrated Analytics and Support at Linquist, where he also leads work on data analytics, AI/ML, data engineering, and software development to support national security customers. Kevin is a retired Air Force colonel. His key assignments include 4 squadron commands, 2 of which were deployed, and tours at the Air Force Logistics Management Agency. Kevin earned a PhD in Operations Management and Decision Sciences from Indiana University. With that, I want to turn it over to Dan and Kevin. Appreciate your time and your willingness to educate our audience, and over to you for your presentation.
Great, good afternoon. I think Kevin's going to go ahead and push some slides here. All right, well, Kev's getting.
But I do.
Yeah, perfect, Kev. Well done. So thanks, Arun, for the wonderful introduction. You gave half the brief for us, I think, which is fantastic. So as recently as 5 to 10 years ago, we would talk about competition between companies or organizations. But as the role and importance of supply chains has expanded and increased over the last few years, we start to hear more and more about actual competitions between supply chains. And that notion or that idea certainly rings true when we're talking about the U.S.'s defense industrial base and our respective supply chains. Recent news cycles are absolutely littered with supply chain horror stories, right? So everything from COVID-19 to state-sponsored cyber attacks and even most recently kinetic attacks on commercial shipping lanes in the Red Sea. Each of these events highlights the fragility of our global supply chains. And while a poorly designed or poorly managed supply chain can be a vulnerability, A well-designed and well-orchestrated supply chain can eventually become a competitive advantage. And one way that companies are trying to mature and significantly improve supply chain performance is by digitalization. All right, slide. So that's what we're going to talk about today, right? First and foremost, we want to talk about what is a digital supply chain, some of the differences between a quote unquote traditional supply chain and a digital supply chain, as well as some of the key components and emerging technologies that are used as part of these digital supply chains. Then we'll talk briefly about why you should care, where the DoD is in terms of its progress and some of the recent initiatives. And then we should have plenty of time for questions and comments at the end. Slide. All right. Before we begin talking about digital supply chains, let's just talk real quick about what a quote unquote supply chain is, right? So you guys all, I'm assuming are familiar with this, but just as a quick refresher, a supply chain is nothing more than a network of companies or organizations that are involved in the production of some type of commodity or the delivery of some type of product or service, right? In general, you have nodes within a supply chain or supply chain partners orchestrated or organized in some type of linear or chain-like fashion, and products and services flow down the supply chain, everything from the harvesting of raw materials to the making of components or subcomponents, the ultimate manufacturer of a finished good, and then the distribution of that good to a retailer and then eventually to its customer base, right? While products or services generally flow down the supply chain, payments or some type of financial transactions flow up the supply chain. The customers pay the retailer pays the distributor, et cetera, et cetera. Slide. The other key aspect of a supply chain is the information flow, right? And obviously information can flow either way, both upstream and downstream within a supply chain. But one of the things that plagues, I'll say, a traditional supply chain is that information flow typically just happens one link upstream and one link downstream. So in other words, the manufacturer is pretty much just communicating with its immediate upstream suppliers or its first tier suppliers. And then it's typically communicating with its downstream, say wholesaler or distributor. It may not have direct interaction with its end customers. It may not have, direct interaction with the companies or organizations that are harvesting the raw materials, or even, second through end tier suppliers. So the amount of visibility and information flow in a traditional supply chain is somewhat limited. Now, each echelon, to its credit, will try to optimize its performance, but it's doing so based on a limited sight picture in terms of how everything is integrated across the larger supply chain. So a manufacturer may be trying to optimize its throughput or its production schedule. Maybe it's trying to minimize its work in process, but it's doing so based on recent information that it has from its first tier supplier or from its demand signal that it's getting maybe from its wholesaler or its distributor. It may not necessarily know exactly what the sentiment is among the ultimate customer, and it may not have any visibility of any further upstream suppliers, those tier 2 to tier N suppliers. So while it can try to quote unquote optimize its performance as that OEM or as the manufacturer, it's doing so with limited information or limited sight picture. All right, slide, please. All right, so let's talk now about a digital supply chain. A digital supply chain, first and foremost, is still just a supply chain, right? It's the same set of partners or key stakeholders as in that traditional supply chain. The difference is a much greater level of interconnectivity or integration between those partners. And that interconnectivity is created by a significant increase in the amount of information available to each of those nodes, as well as the information flow between nodes. So the fundamentals haven't changed. Each node in the supply chain is still trying to do traditional supply chain management activities. It's still trying to forecast demand, do basic demand planning or supply planning. It's still doing those procurement type of activities, warehousing, distribution, asset management activities, et cetera. But it can do it more smartly, more efficiently, more effectively, because it has far greater information at its disposal. Slide, please. So how does it attain this information? It leverages technology. A digital supply chain leverages advanced technology to capture or collect far greater information. It uses everything from sensors on specific machines, sensors on packages that are being shipped throughout the supply chain, communication between various nodes, et cetera. Digital supply chains rely on automation. So we're not trying to move goods or services on the backs of humans, right? So we've got automated warehouses, automated distribution capabilities, automation in our manufacturing facilities, et cetera. Data sharing is perhaps the most foundational component of digital supply chains. Various nodes throughout the supply chain have to enter into information or data sharing agreements to make sure that various nodes are willing to share certain types of information at certain times in certain quantities, et cetera, to enhance the amount of visibility that various nodes or various partners have throughout this new supply network. And what that information affords us is an opportunity to perform far more robust analytics. So instead of trying to build out a monthly production schedule based on last quarter's demand, we have the ability to do far more advanced analytics, maybe even predict certain outcomes throughout the supply network, and maybe even prescribe certain solutions to mitigate certain risks or certain negative outcomes that we may be able to foresee based on this additional data that is being shared and these advanced analytics that can be performed based on that data. Slide. So what does that get us, right? So all of this data collection, information flow, information sharing, this more interconnected supply chain or supply network gets us things like more connected customers. We're dealing with more than just traditional transaction histories. Customers have more information in terms of what's happening upstream in their supply chain. So they've got more visibility in terms of when things will be released out of production, shipping schedules, expected delivery times, et cetera. So those customers can make more informed decisions. Bottom line is these digital supply chains can help to achieve more effective and more integrated customer engagements throughout an entire product or service lifecycle, which obviously enhances the overall customer experience, which improves overall operations. Intelligent supply is everything that involves really sourcing goods at best value. So we're talking about more efficient procurement processes, improved supplier relations, reduced risks associated with ordering too much inventory, too little inventory, ordering inventory too late, et cetera. We talk about synchronized planning. Man, we're talking about being able to integrate your strategic goals with your financial objectives, and even blend those in with more tactical supply type decisions. How am I going to set up my distribution network? How am I going to build production schedules, et cetera, right? But the key here is to be able to foster faster, more cross-functional decision-making, leveraging enhanced visibility to ultimately lead to a better customer experience, a more agile or more responsive supply network, and more collaboration between our supply network partners. Smart operations, and we're going to talk a little bit on upcoming slides about things like smart factories and smart warehouses, right? But anything that we can do to synchronize production and operations to drive improved performance by collecting more information on the factory floor, et cetera. Kev, you can go ahead and go to the next slide. So some common components in a digital supply chain, and not that in order to have a digital supply chain, you have to have each of these components. These are just things that we're starting to see more and more frequently as various companies try to digitize their supply chains. You start to see certain things like smart factories and even smart depots within the defense industrial base. When we talk about smart factories, we're talking about manufacturing facilities that leverage things like computer-aided manufacturing or computer-integrated manufacturing, plenty of autonomous operations within their facilities, advanced protocols and standards. They leverage sensor technology. They have interconnected communications, so machine-to-machine communications, machine-to-human communications, et cetera. You start to see things like digital twins of the manufacturing systems, as well as digital twins of the components being produced in these facilities, et cetera. Conditions-based maintenance, product lifecycle management systems that can digitally track product life cycles everywhere from design to manufacturing to use all the way through the disposal of that particular item at the end of its life cycle. Similarly, smart warehouses, they leverage things like automated picking and stocking technologies, right? So I don't know if you've ever walked into an Amazon warehouse, man, highly automated, right? You also have things like optimized order picking, so advanced algorithms that will tell you which items to pick in which sequence to minimize the amount of work required to try to fulfill all those orders within a set period of time. And ultimately, smart warehouses are designed to maximize the human operator efficiency or to minimize the amount of manual workload, as well as to get property moving throughout the warehouse as quickly as possible. Smart logistics, same type of concept, right? We're talking about optimizing distribution networks as well as routes, leveraging sensors to measure everything from temperatures in, say, food and pharmaceutical supply chains, automated asset visibility, leveraging technologies like RFID or radio frequency identification to be able to understand exactly where certain assets are at any particular point in time. Some of this technology is passive, some of it's active. But the key is to be able to improve visibility of assets as they flow throughout your supply chain. We talked about a significant increase in information availability and information sharing. Man, you have to be able to store that information somewhere so that you can do basic data processing and some analytics. And the cloud-based systems have significantly enhanced our ability to store and process information. One of the beautiful things about the cloud is not only is it easy to access data, but it's also easily scalable, right? So as your data increases, as your data requirements increase, you have the ability to match that demand. And it also, cloud-based storage supports things like ERP systems or enterprise resource planning systems that Kevin will talk about here in a little bit, software as a service, et cetera. And then obviously digital platforms, and this can be anything from automated procurement systems, purchase to pay processing type systems, strategic sourcing activities, et cetera. So more and more of those traditional supply chain functions are being digitized and being automated. Now, in addition to those, what we call common components, we also see supply chain starting to leverage emerging technology. And probably in no bigger way than just leveraging the Internet of Things, right? We're all familiar with IoT. Our refrigerators at home automatically tell us when it's time to replace filters. We can remotely change our thermostat settings before we even get home. Everything is connected via the internet these days, right? And the supply chain is beginning to leverage that type of technology to be able to track certain things, to be able to track the performance of certain machines, locate certain assets throughout the supply chain, et cetera, right? So we're talking about leveraging everything from RFID, wireless sensor networks, machine-to-machine communication. So a machine downstream in a manufacturing facility may know if there's a bottleneck or a problem with the machine upstream on that same assembly line. Obviously, a ton of information available through mobile apps. Delivery drivers can track the status or delivery of certain shipments and transmit that in real time or near real time upstream in the supply chain as well. So the Internet of Things can basically be used to virtually control various aspects of the supply chain, optimize functions within the supply chain, improve planning, improve our ability to monitor certain supply chain activities, et cetera. So certainly a powerful tool. Another emerging technology is distributed ledger technology, or what's commonly referred to as blockchains, right? And we've heard plenty about blockchains and everything from cryptocurrency to supply chain type functions, right? But that distributed ledger technology basically provides us what we consider an immutable record of transactions, right? It's a true and accurate record of activity within the supply chain between certain partners who have agreed to share information or data. And everybody is looking at the exact same status, the exact same set of transactions, et cetera, throughout that blockchain. And anytime anybody makes a particular transaction, everybody has instant visibility of what transaction or what change has been recorded in that digital history. Digital twins, we talked about a little bit before, right? But just that digital representation of everything from a product to a system, whether that's manufacturing, a capability, a machine, a distribution network, et cetera. You can make a digital twin out of just about anything, right? But understanding how your supply chain is performing or how it could perform under varying conditions, it's easier to play around with that in a digital environment using a digital twin than it is to just see how your actual supply chain will work, right? So 5G, man, we talked about cloud-based storage and the capabilities that the cloud can provide. 5G just provides far greater bandwidth and the ability to transmit more data. So as supply chains become more digital, they're collecting more data, they're transmitting more data. 5G technology affords us to be able to keep up with the demands of that increased data flow and data processing needs. And then obviously the question becomes, where do I want to do some of that data processing, right? Do I want to do it in a centralized environment like the cloud, or do I want to try to push some of that compute power closer to the point of use, closer to where the sensors are collecting the data, or closer to where decisions are being made or that data is being used? And edge computing and fog computing basically allow us to push that data processing closer to the point of collection and point of use, which enhances reliability as well as reduces the latency in terms of being able to process that data. Ultimately, the point of digitizing your supply chain is to be able to capture more information and, more importantly, share that information throughout your key partners within your supply chain or throughout your supply network to be able to make better decisions faster. And you do that through the use of advanced analytics. A lot of supply chains, many supply chains are starting to use artificial intelligence. They're starting to use machine learning to identify patterns in data, to be able to predict certain outcomes, and ultimately to be able to prescribe certain mitigating actions to preclude negative events from occurring in your supply chain. And that's becoming extremely commonplace today. All right, slide.
Hey, Dan, before we roll on, I'm kind of monitoring the Q&A, and there's one on cybersecurity that I think we'll hit a little bit, but Jacob Wynn has been very active here, and he's asked a few questions that I think we can probably catch up on now.
Yeah, fire away.
So the first thing he asks, are there digital supply chain industry standards? And if so, are they sufficient, or is work needed? If not, should there be standards? And I think I think the answer to that is there are standards on components of digital supply chain.
Right. So there is no industry standard for overall supply chain digitalization. And I'll be honest with you, one of the challenges, and Kevin's going to kind of walk us through a laundry list of challenges. One of the problems that we have is the lack of a standard lexicon or ontology within supply chain. So as you look to collect information and share information between or among supply chain partners, one of the things that you first have to try to do is figure out, are we talking about the same thing? Are we speaking a common language? Are we capturing data in similar formats so that they can be transmitted or can be communicated effectively? And certain organizations or certain supply chain partners have figured that piece out. For others, it's a legitimate struggle, and it is absolutely impeding progress or delaying the implementation of full supply chain digitization, or making it significantly increasing the barriers of entry, making it more costly in terms of either money or time. Hopefully that answered the question.
All right, another Jacob. I'm gonna. There was one in there from Anonymous, talking about cybersecurity, and we're gonna talk about cybersecurity a little bit as one of the challenges. So I'm gonna skip over that for now. So whoever you are, anonymous attendee, we'll come back to you. Jacob asks also, how much of this can be automated, and how do these systems integrate human input and communications? And I think the short answer is it can all be automated.
Yeah, and really what you're talking about is system to system communication, right? So
Yeah.
figuring out how to flow electrons from one organization. Really, some of that is intra-organization. So how does the manufacturing entity in one company talk to its warehouse or talk to its distribution function? A lot of times a single company has different systems and even struggles to be able to communicate or disseminate information in an effective manner. So you need APIs. You need something that can translate data and disseminate data. And you're seeing more and more of that in terms of the intercompany communication as well, right? But you've got to have a mechanism where you can pass information from one node or one partner in the supply chain to others.
Yeah.
And you're starting to see more and more try to find, common IT systems, common infrastructure to facilitate the flow of those electrons.
And on the human input, that's a, ongoing debate. It sort of depends. I mean, I hate to give you that answer, but it sort of depends, because there are a lot of things that that can be automated very easily, that are very transactional, that don't require any real high level thought. There are a lot of other things that you want a human in the loop. You want a human you want a human or computer interface with a human who has to make a decision on something. So it sort of depends, and you have to make those calls along the way as you're configuring your digital supply chain, or all the components of your digital supply chain. So
and all of that. So whether you have a human in the loop or just a human on the loop, or you actually refuse to automate certain decision making, right? It depends on your level of confidence in your data, your level of confidence in your algorithms that are helping to make predictions or helping to prescribe solutions as well, right? So I don't know of too many supply chain functions that are fully automated, although on the next slide, I'll kind of walk through one Amazon example.
Yeah.
But I think we're maturing beyond human in the loop to human on the loop. And then eventually there's certain supply chain functions that will be able to just be fully automated.
Yeah. And Jacob asked about worrying about data sharing. Jacob, I'll table that one also, because we have a slide on that.
Yeah, huge problem, right? So a lot of this relies on in-depth negotiations in terms of what information will be shared, who it will be shared to, whether or not it's proprietary. So yeah, information sharing is a huge issue and certainly a challenge.
Yep. He also asked, what's the difference between he asked about the distributed ledger blockchain. I think you got that one. I think you got that one. Then there was another from Anonymous. What's the difference between edge and fog computing, and the implications of fog computing for DSC?
Oh, sure. So real quick, I mean, when you look at edge computing, you're talking about just bringing data processing closer to the devices or closer to the sensors that generate the data. When you talk about fog computing, it's essentially edge computing, but you're creating certain clusters of sensors or clusters of compute centers. So you combine certain edge computing capabilities basically to create fog computing. So it's a similar concept.
And then the last one, I think for now, is how does data interoperability come into play between these services? And I assume they're meaning across these technologies and capabilities, it's a good question.
Yeah, and you're going to touch on that on the challenge one too, or do you want to try to address it now?
Yeah, we can table that till I get to it.
Okay, but yes, certainly an issue.
Huge, yeah. And more so, I'd say just for now, I mean, more so than data interoperability, because technology has sort of moved us past, what we used to think of as interoperability. It's more data consistency and data meanings, data definitions. When you start getting across systems, across a network, different things mean different things to, different terms in different fields mean different things to different companies. So that's more of a challenge than I think than the interoperability at this point. But
and that's why that ontology is so important. And there's organizations like ASCM that are trying to define a standard lexicon or create that standard ontology. But there's a lot of work to be done there. Okay, so I don't need to go point by point. We certainly kind of talked through this over the last couple of minutes, right? But that compared to the traditional supply chain, think of something in a near linear format with limited communication. You're basically just communicating one link up the supply chain or one link down the supply chain. That digital supply network significantly enhances information share, has the potential to significantly enhance information sharing, which creates additional visibility. It affords you the opportunity to predict and prescribe, like we've talked about, using some of that near real-time data visibility. It can be far more responsive to changes in either downstream demand or upstream production. And we talked about human in the loop, human on the loop, and ultimately it can allow you to make more strategic decisions throughout your supply chain, right? So in a traditional supply chain, we've talked about optimizing performance at a specific node, right? Whereas with a digital supply chain, we have the opportunity to try to balance much more strategic level decisions, right? So I can talk about balancing my operating costs or balancing my profits with expected service levels or maximizing, end customer experience, et cetera. Everybody on this call is familiar with Amazon. Many of us use Amazon, right? Several years ago, Amazon actually implemented their predictive shipping model. So we talk about being far more responsive by digitizing your supply chain. Many times, Amazon will actually ship products before a customer actually places an order. And then once that order is placed, there's certain goods already in the distribution network. And Amazon has the ability to identify those items throughout their network and redirect assets that are already in transit to the closest customer, or that they've got different ways to run their algorithms, right? So I can redirect certain assets in such a way to minimize delivery time, minimize delivery costs, et cetera, right? So as soon as Kevin here puts something in his shopping cart, whether or not he's clicked the buy button or not, it can run algorithms to figure out what probability Kevin is actually going to actually place that order, and it can start moving stuff proactively. If Kevin decides not to actually purchase that item, well, that item's already in transit and it can be redirected to the next customer that purchases that item. So again, I mean, just by having that visibility and having the ability to communicate with everything from its distributors, whether that's an Amazon distributor or one of its third-party providers, as well as its distribution network, whether that's an Amazon delivery outfit or its UPS or FedEx counterparts, it has the ability to implement things such as its predictive shipping model. So just one quick use case of how digitizing your supply chain has led to increased performance and certainly increased user experiences. All right, I think I'm going to go ahead and turn it over to Kev. Kev's going to talk about why we care and kind of sort of some of the barriers to entry and where we are from a DIB and an OIB perspective. So Kev, I'll go ahead and turn it over to you.
All right, thanks, Dan. So I'm not going to spend a lot of time on this slide because I think especially for this audience, you already care. You care enough to sign into this webinar, right? I think you probably all understand why we care, but from a DoD perspective, I mean, there's no getting around. Logistics wins wars. So effective and efficient supply chains are really pivotal to all of that, to winning wars. It's that critical. We've always had this love-hate relationship with efficiency in logistics. Typically in wartime, we want to be effective, and in peacetime, we want to be efficient, right? And it sort of the pendulum swings back and forth and is usually a year or two late when something kicks off. So but one of the things that really came out, and so we learned this lesson over and over again during wartime, especially if we don't have a whole lot of time to ramp up, which we typically do. One thing that, a recent event that we all lived through is sort of the COVID shutdown that in a very real way exposed a lot of our supply chain wide fragilities and in a way that probably most wars don't. Like I said, in most wars we have some ramp up time. We know it's coming, and we can kind of control the pace of our buildup. When something like COVID happens, or a lot of humanitarian, hurricanes, tsunamis, those types of events, Those, and because COVID was so large, more so than a tsunami or a Hurricane Katrina or those types of events, it really almost instantly exposed all of our supply chain weaknesses. Not only for products and parts, but also for the raw materials that go into the products and parts. So if anyone's tried to buy a car in the last few years, you know exactly what I'm talking about. But it gets, for DoD systems, it's critical because a lot of the raw materials that we use in most of our electronics, most of our DoD systems now are controlled by countries who, and especially one country that's not necessarily our friend. And so when we're relying on that and we suddenly have a big, huge supply chain wide disruption, that becomes a real issue in real time. So because of that, and this type of thinking isn't anything new, but because it's so raw on the heels of COVID, the government DoD has really been hitting it hard in the guidance lately. So that's that's sort of your second reason to care, is that it's being laced throughout all the publications that a lot of you are used to reading. National Defense Authorization Act, the newly minted National Defense Industrial Strategy, which was just published for the first time in 2023. So that's a new publication. The Assistant SecDef puts out his strategic plan, and all of these are using similar words: digitization, efficiencies, advanced analytics, data integration. A lot of the same buzzwords. Frankly, in a lot of these documents, you'll see a word salad when they write these, but the intent of all of them is to underscore the need for digitizing and building a real digital network around our supply chain. And then just the nature of physics. Our weapon systems today are increasingly complex, increasingly networked by design. So think F-35, think autonomous vehicles and autonomous fleets of aircraft. That all requires a ton of information sharing just to pull it off. And so not only are they becoming technologically more advanced, but the requirements for networked information is more and more technologically advanced. So we have to modernize our supply chains to keep up with that. And in fact, in the case of the F-35 and others, the supply chain is sort of built into the system itself, into the weapon system itself. So where the platform ends and the supply chain begins is sort of a gray area. And that's just underscores again the need for a digital ecosystem where everybody can kind of share information. Multiple organizations, multiple consultant organizations especially, have done a lot of studies on this. I put up a few here just as a representative sample. Now, some of these obviously don't really apply to DoD. I mean, they do. We care about customer service, sort of. But given that, we only have one place to buy an F-35 or to buy whatever, customer satisfaction isn't typically integrated into our thinking. Certainly cost is, certainly perfect order fulfillment or on-time delivery, lead times, inventory turns, those are all things that we really care about. So even in the DoD, from a DoD perspective, some of these should jump out at you as pretty significant gains on the DoD side. On the commercial side, obviously there's a huge upside to it as well, especially when you start talking about rework and scrap rates. That's huge. If you can reduce your rework of scrap from 20 to 50%, that's huge. Obviously, there's a huge cost associated with that as well. So, just a snapshot of what some of the leading consultant firms are saying based on their studies and their surveys. Another reason to care. All right, let's step through. I'm going to step through these kind of left to right and top to bottom. And some of them have already been brought up in questions, but First risk, and I'm kind of lumping these together. Some of these are risks and some of them are challenges or roadblocks. Some of them are a little both. Costs is obviously always a concern. Someone asked about the cost factor. I'll come back to that one, but the problem with the cost factor is that when we talk about centralizing and building a supply chain that kind of all operates on one network of information, there's a cost associated with that. And so what typically happens is we take kind of an incremental approach and we try to prioritize and take care of those information flows that will give us the most bang for the buck, because typically it's going to cost too much to do it across the board. And when the DoD has tried to do that, most notably with the Air Force's ERP system, it's been a disaster. So many billions of dollars have been spent, and a good chunk of that has been wasted on capabilities that didn't materialize. So you always have to be concerned with cost, and you have to take an approach that's sort of an incremental approach that mitigates some of the risk associated with that cost. That second one is really just kind of an illustration of, hey, in this Internet of Things where we have data and sensors and systems and all trying to funnel into one picture. And this kind of gets to one of the questions that was asked earlier. How compatible is all of this data, and how much can you trust what's on the little computer screen underneath that we're funneling it all into? Part of it is interoperable data, but it's more it's what the data means and how it's defined. So it's really important when you go through this, and again, that drives cost. It takes time to do that. Takes time to define all the different data elements that are funneling in. So that becomes problematic, because it's not like you can just flip a switch and make this happen. So again, you have to sort of look at everything you want to do and have kind of a triage approach to attacking the biggest bangs first. Cybersecurity, I'm not going to get into this a ton, because I think everybody realizes that the more you share data, cybersecurity becomes a huge issue. There are a lot of technologies in the cyber world that are starting to make it easier and easier to do this, to lock down certain parts of data, maintain privacy and ownership in different pockets of data. In fact, one of the things that NDIA has been spearheading is kind of a proof of concept on a DoD use case where, hey, what if we have a weapons system that has multiple contractors, in addition to the OEM, multiple tiers of a supply chain? What if we pull all their data together and show what's possible, but also show that we can maintain privacy and security of each individual silo of data? Because there is data technology to do that now. So this is becoming more and more of an issue, because I think we've had two competing interests for a long time. Everybody wants data. Everybody wants all their data on a cloud where they can merge it and they can integrate it and they can get the full site picture. But on the same token, they're holding back because there's privacy concerns, IP concerns to some extent, and cybersecurity concerns. So no easy answer to that, but the technology is rapidly improving. So data sharing kind of similar, especially in the DoD. So there are two things going on with data sharing in the DoD. One is just what I was just talking about, right? Companies will always want to protect their IP. They'll always want to make sure that their data is secure and make sure that their data isn't getting out to a broader audience that can use it against them. So I think there's always that concern. That's more on the cybersecurity side. The other piece that always comes into play, and most companies won't admit it, but it's true, they don't want to share their data because they want the government to rely on them for their data. They want them to pay them for their data. And to an extent, the more you sort of hoard your own data, the less the government, or the more the government will rely on you. So There's a business aspect to it. Like I said, you'll probably not get too many companies to agree that that's the case, but that is sort of the case. So another challenge, another hurdle to overcome. Interoperability, I think we talked a lot about that. I mean, data is data. There are different sources. The more and more you start getting video and audio sources, and you get, I mean, the technology for other things like PDFs and scans and that kind of thing is I think that, you know, that's well enough mature that we can integrate those types of data fairly easily now. But like I said, where you get into the real heavy lift, it's particularly in a big supply chain, like the DoD's, where you have multiple OEMs, you have, you know, literally hundreds and hundreds, thousands of second tier and third tier suppliers that are supplying the bigs. You know, multi-echelons, multiple different companies operating everything from advanced ERP systems to a spreadsheet on a laptop in someone's garage and everything in between. And everybody's sort of calling things what they call things, right? What it makes sense to them. And when you start pulling it all together, it doesn't necessarily all make sense. And that's an extreme example. Even when you look within the DoD, across the DoD, the different services all call things different things. A lot of naming conventions, a lot of definitions are different. Even within services, you have that problem. So Dan and I grew up in the Air Force supply chain world, and even within the Air Force supply chain, organization to organization, there were always a lot of disconnects between what data meant, depending on who you were and where you sat and which system it came out of. So that's the greater risk and the greater challenge and the greater cost when you talk about data interoperability. Trusted information.
Hey, Kev, we've got about a minute before we want to kind of turn it over to questions. So
okay.
I just kind of skim the wave tops here and then kind of cover the last slide.
Yeah, that first guy went a little long.
Yeah, I apologize.
No, that's all right. Trusted data privacy. We talked about trusted information is obviously important. Traceability is very important. Again, the bigger your supply chain, the harder it is to trace it back to the source. Regulations are always an issue. I probably don't have to say much about that. Data governance has come a long way. That's an important part to make sure that your data is being input correctly, has common definitions across the supply chain, is traceable, is valid, and all that stuff. So data governance becomes sort of the mechanism to do that. And then change management is change management, right? Anytime you're changing or automating, there's going to be a change management component because people are affected. And then the final one is the skilled workforce. And that's where I think we're lacking in DoD logistics. We do a very good job of training our logisticians to do logistics. We haven't, as technology has advanced, we haven't done a very good job of training our logisticians to do technology. And unfortunately, that's sort of coming back to bite us now. All right, finally, how's the DoD doing? I mean, the short answer on this is we are sort of digitally immature in the DoD. They lag significantly when you think about the Amazons and the Walmarts that have very advanced supply chains and they're very networked, very digitized. DoD ain't that. DoD, for a variety of reasons, mainly because they're very stovepiped, both organizationally and in budget, just haven't progressed in a way that has moved the needle significantly. They've also had some fits and starts. Like I said, with ECSS was a prime example in the Air Force. Their attempt to implement an ERP system, which went 8 years and $1 billion and amounted to nothing. But there are some better examples of, like, the Army I have on the slide. The Army is actually implementing an EBS convergence systems, EBSC. So they're trying to consolidate all their existing ERP systems. DLA is doing something similar. And obviously there's a lot of bits and pieces. There's a lot of work being done with smart warehouses in pockets. There's DLA, I talked about their warehouse management system. Based maintenance plus is being done well in pockets, but again, there's data limitations there. And same with advanced manufacturing techniques, especially additive and digital manufacturing. Those are being done, but in pockets. So none of this stuff is really spread in a enterprise way across the DoD, unfortunately, at this point. So that's why we sort of pin the needle at somewhere between digitally immature and digitally enabled. So there's a long way to go, a lot of work to do, and unfortunately a lot of cost associated with that. So, and that's my get off the stage slide. So we'll let me open the Q&A back up.
Hey, Kev, real quick, can you just go to the backup slide that we
Yep.
show this, because there's been some questions about interoperability, right? And it's a valid question, and it's one of the things that kind of drive Kevin and I crazy. We talk about the complexity of the DoD's global supply chain, and how it's harder than most. And I think we would counter that managing the DoD supply chain, especially when you start talking about the organic industrial base, could potentially be easier than other supply chains if we improved our interoperability, right? So we have at least 6 different supply ERPs between the 4 departments, right? I mean, that's utterly ridiculous. The fact that each service has at least one, if not multiple supply ERPs, and these ERPs don't even talk to each other, right? So it's not easy for the Air Force to go out there and just easily order a part from the Navy if it doesn't have one in stock, even though it may be a common part. DLA uses a completely different system than any of the services do, et cetera, right? So, Kevin talked about the DoD customer. It would be ideal if any warehouse, I don't care if it was a Marine Corps warehouse, an Air Force warehouse, an Army warehouse, et cetera, had the ability to talk to each other and had the ability to share information about common parts, common status, et cetera. The DoD owns its own distribution capabilities through both DLA and Transcom, right? And it would be a whole lot easier if we were integrated. And then obviously manufacturers, we don't own the OEMs, but the DoD does control things like its depots. And the Air Force depots alone don't talk well to each other. But imagine if they talked well with each other, and imagine if Army depots could talk with Air Force depots, could talk with Navy depots, et cetera, how much we could potentially improve supply chain integration and overall supply chain operations. So yes, your point about overall interoperability is valid, and it is a glaring weakness in our current supply chains, and it's got to be a point of emphasis if we're ever going to realize the full potential benefits of digitizing our supply chains. Kev, I think, go ahead.
As I'm scanning through here, there's several that I think we can hit with one stone. Our DSCs incorporated into war games, TTXs, theater exercises. Any lessons from those? Short answer is no. So that's an easy one.
With the exception of cyber, right? I think everybody generally agrees that our logistics, IT infrastructure, our systems are vulnerable, and we're starting to see more play with respect to cyber attacks or cyber vulnerabilities and the potential impacts. But outside of that, we're not making a concerted effort, not nearly as concerted effort as we would like to see in terms of trying to model the positive effects of leveraging DSCs to their full extent, or some of the inherent vulnerabilities. Supply chains themselves are getting war gamed, but not necessarily DSCs specifically beyond just the cyber piece.
Yeah, and I would say that the war games, TTXs, theater exercises, et cetera, those are exposing, because of the scenarios they're playing out these days in those contested logistics and that type of thing. Because of the scenarios they're playing, the war game itself will expose the fact that we need to digitize, but the digital supply chain is not being explicitly played. So there's another one that any sense on how digital adversary supply chains are? I have no idea. I would guess just because of the nature of their centralized approach to everything and their centralized planning and funding, that China would probably be moving in that direction a lot faster than we are, but that's a guess.
There's varying levels of success, right? I will tell you that we have intel communities that are focused on assessing adversarial supply chain capabilities, as well as vulnerabilities, and looking at ways to exploit certain vulnerabilities in our adversary supply chains, much like we're confident our adversaries are doing with us.
Hey, let me jump in here. First, thanks for that presentation, and you still got questions trickling in here. Let me ask two, actually. One is inputting data into this digital supply chain seems like partially something you can automate, partially a human task. So are you in some sense creating more work for people at the depot, on the flight line, to record more information, to provide the ability to do some of this data sharing and information management?
That's why you're trying to automate the capture of a lot of this data, right? Through increased sensor technology, passive readers, passive scanners, and then fairly easy point of use data collection. So instead of having that maintainer who executes some type of maintenance activity, go back to a desktop back in a hangar and manually input maintenance records or whatever, be able to significantly improve the data capture on the flight line by the aircraft, et cetera, to ease that data collection or greatly improve the data collection.
And one more, I'm just channeling my boss, David Norquist. I'm going to think I know the answer to this. Auditing the Pentagon has been a big challenge forever. Does this digital supply chain actually improve the ability to do internal management controls, to do inventory controls, to, in the end, pass a financial audit?
Yes,
Absolutely.
there's no doubt about that.
We'll do one more question. There's the cybersecurity question, Kevin. You know, the digital nature of this, the inputs, does it increase the attack surface for cybersecurity? Does it increase the cybersecurity challenges for the whole logistics chain?
Yeah, it always will. And that's part of the concern with when Dan was talking about edge and fog computing, and that's part of the reason why you do that, right? To the extent that you can keep data and processing closer and a little bit more distributed, it sort of limits that exposure. But yeah, I mean, there's no way around it. The more information you share, the more vulnerable you are to cyber attacks. But luckily, like I said, the technology, cyber defense especially has come so far. That's getting very highly automated and very highly effective as time goes on. So
with that, I'm going to have to call the Tech 101 session to a close. Thanks to Kevin and Dan for their great presentation. Thank you all for your attendance and the great questions. We'll post the recording online, and with these guys' permission, we'll post the slides online as well as soon as possible. If you have feedback about the Tech 101 series, especially topics you'd like to see us cover in the future, please email us at eti@ndia.org. I want to take this opportunity to highlight a few upcoming events. The 38th Annual National Logistics Forum is going to be held at February 6th and 7th in Oklahoma City. That's going to cover some of the issues we talked about today with digital supply chain and digital material management. Registration's open now. You can go to the NDIA events website to get more information. The next Tech 101 is February 21st, 1 to 2 p.m. It's on Digital Twinning 101. Registration will be open soon again at the events website. And in March, in the Tech 101 series, we'll be doing Forever Chemicals 101. And that's March 14th. Again, register at the events website. I also want to point out that the second Emerging Technologies Conference, last year's was the first, great success, will be held August 7th through 9th at the Washington Convention Center. More information will be coming out on that for registration, sponsorship, displays, etc. Thanks again to our speakers, Kevin and Dan, and appreciate everyone attending this month's Tech 101.